Hi everyone, in this video we are going to learn how do things become hotter or colder. At the first part you see some particles here. First one, there is a particle which has only one parenthesis around it, and the second one there's a particle, same particle, which has two parentheses around this. And it means that the first one gained energy, heat energy, so its temperature gets higher. After the third one, there is a particle, same particle, but in this one, it has three parentheses around it, so it means that it gained energy, heat energy. So at the first part, it was cooler. Meanwhile, it gets hotter. The other one, as you see at the first side, the particle has three parentheses around it, and it lost energy. Then the particle has two parentheses, and it again lost energy, and the particle has only one parenthesis. So in meanwhile, it gets cooler. Now we're going to learn about thermal equilibrium. As you see, there is an object which has some particles. At the first particle, there are three parentheses. At the second one, there are two parentheses, and at the third one, there is only one parenthesis. When they come together, they will give energy to each other, and at least, as you see, each particles has two parentheses around them. So this means thermal equilibrium, and we are going to learn about it. Thermal equilibrium. We are going to learn about it. So sorry about my writing. So if an object becomes hotter as it gains heat energy and cooler as it loses heat energy. Now, kinetic energy. Kinetic energy is an energy formed because of the motion of the objects. At the first diagram, an A diagram, you see some arrows around the particles. And B1, you see these arrows also, but if you compare these two with each other, the arrows at B side is longer than the arrows at the A side. So this means that the B side has much more kinetic energy than the than the A part. So it means that B is hotter than A. A is cooler and B is hotter. Now, as you see in this diagram, we have a metal strip, and we start to heat this metal strip on the left side. If you follow the arrows, the dark red side is A, the middle side is B, and the right side is C. So if you look to the particles, the A side particles has three parentheses around them. It means that this part is hotter, and the C part has one parenthesis around it. It means that this side is cooler. So we can say that when it gets further from the heat resource, it gets cooler. When it's near to the heat resource, it gets hotter. I'm going to correct this. Cooler, yes. Now let's going to answer these questions. Which part of the metal rod is hottest? As we see, it's near to the heat resource, so A part is much more hotter than the other one. Which particles are moving the most? Let's go and remember, if the particles has more parentheses around them, then it means that it's much more hotter and it moves faster. So A part has much more parentheses than the other ones. It means that it's more faster than the other ones, and also it has most kinetic energy from the other ones. Heat flow direction. Heat energy flows from A side to C side, because always heat flows from hotter one to cooler one. Now it's time for conduction. Conduction is the heat transfer from the more energetic particles of a substance to the adjacent less energetic ones as a result of interaction between the particles. In gases and solids, conduction is due to the collision and diffusion of the molecules during the random motion, but in solids, it is due to the combination of vibrations of the molecules in a lattice and the energy transports by free electrons. Now we talked about it. We said that the heat transfers from hotter areas to cooler areas. So when you put a hot object and a cooler object near to each other, and when they touch each other, the heat will flow from hot one to cooler one until they reach same temperature. And we call this thermal equilibrium. So this one is hot one, this one is cold one. It means that the heat will transfer from hot one to cold one. You see there are two objects, A block and B block. A block is hotter one, B block is cooler one. Maybe you can understand from their colors. Hot is shown with red, cold is shown with blue. When we put them together, when they touch to each other, heat will from A to B because heat always flows from the hot one to the cold one. At least when they come to same temperature, when they reach the same temperature, the heat flow will stop and thermal equilibrium is the one that we called thermal equilibrium. You can see thermal equilibrium here. There is an object with hot particles with 3 parentheses around them, and there is another object with cooler particles. There's only 1 particle around them. When they touch each other, the hotter ones will give energy to the lower ones, the cooler ones, and then their temperature will be common, and this is called thermal equilibrium. They all have 2 parentheses around them. Let's look what we have to know about this subject. There are 3 things that we have to know about this subject. The first one is there has to be temperature differences. If there is a temperature differences, energy will flow from one to another, and the direction of this heat flow will be from the higher temperature to the lower temperature. The greater and larger difference in temperature means that the faster energy flow. Last example for this subject, and this is warmer and this is cooler. So it means that the heat will flow from warmer one to cooler one. You can write here warmer to cooler, or you can put an A for this, an A B, and a B for this. You can write here warmer to cooler, or if you want from A to from B. See you.